All right, everybody, and we're back again with Keith Pierce, who's a mission specialist with the ARC-2I crew that's here at the North Dakota ILMA habitat. He just completed his 4th mobility test EVA, and so he's going to tell us a little bit about it. Keith, what are we looking at here in this video?
What we're doing here is we're just adjusting the harness that we're using inside these EVA tests. Just to recap, we're trying to distribute the weight between the hips and the shoulders. Additionally, here we're using trekking poles, and so this test we're going to be using both the harness and the trekking poles.
Okay, so before you had no harness, then you had the harness, and then you had just trekking poles with no harness, and now you have both this time, correct?
Yeah, we've got all the tools at play here. So we kind of broke the test down into each of those different parts. Just the suit by itself, suit with a harness, just the poles, and then the suit with the poles and the harness all together. So we can kind of see what each of the different components, the effect that each of those different components had on the actual performance of the suit, and then most importantly, the effects on the analog astronaut within the suit.
Okay, so in these 4 individual tests, what was it that you were measuring? What were you looking for?
We measured a couple different things. First of all, we tried to keep the actual test as consistent as possible. So tried to maintain the 2.7 miles per hour. We did each test for a full hour, traveled roughly the same distance at a comparable intensity. We measured heart rate, CO2 buildup within the suit, the internal temperature of the suit. We also recorded the ambient temperature outside, and I think that's pretty much it. And then just took notes on the actual fit and wear additionally.
Okay, did you see any significant differences between the different mods, specifically with the harness and the poles?
Well, the biggest thing, the biggest indicator of how much impact the suit is having on the actual analog astronaut is probably the heart rate. Seeing as we kept everything else constant, we kept the speed we're going, kind of the temperature. We tried to keep all those things as consistent as possible, and so really the biggest thing we can point at is the heart rate and the heart rate change. And we noticed up to an 18% decrease in heart rate towards in all of the testing in the full range of testing, which is a pretty significant difference. If you look at the actual data here, you can see the initial testing. We had an average heart rate of 133 beats per minute with just the suit, and then you can kind of see as we add these different tools, we added trekking poles, and we add trekking poles with a harness, and as we add all these tools, you can see the heart rate drop as we go. So it culminating at only 110 beats per minute, and really we didn't change a whole lot as far as the intensity goes. We try to keep that as constant as possible.
Okay, so it sounds like you had significant improvements by adding these additional components to the suit, which really improved the wearer's ability to move around and everything. So with regard to space flight and having people on the surface of the moon and then maybe even on Mars, would you recommend these additional components to the EVA suits?
This is an initial test, and it's a case study of just me doing it in a suit. We would want more data with more analog astronauts, and to really solidify it. However, whatever the case may be, it's going to be extremely important that whatever suit the astronauts are using, seeing as you're actually going to have some gravity, albeit less gravity, they will be having to deal with the weight of the suit, unlike in space. So it's going to be extremely important that we do distribute the load properly, so that the astronauts can operate effectively for long periods of time. It'll just increase their overall performance and effectiveness long term.
Well, it sounds really interesting. I look forward to see what you publish after this this analog. Thanks, Keith.
Compass. I'm Rick. I'm Civic.